Hello, everyone. Welcome to our lesson for today. So, in our previous lesson, we have already talked about three different ways of factoring. First one is factoring polynomials with common monomial factor. Second, we have discussed factoring polynomials in difference of two squares. And on the third discussion, we have discussed factoring polynomials with sum and difference of two cubes. And today, we are going to learn factoring perfect square trinomials. Again, before anything else, I want you to focus. Get your notebook and your pen to take notes of the important details. Feel free to replay this lesson if there are things you do not understand. First, we have to know what is perfect square trinomial. Perfect square trinomial is the result of squaring a binomial. It has first and last terms, which are perfect squares, and the middle term is twice the product of the first and the last terms. Example, the perfect square trinomial has a first term of a squared, and it has the last term, which is b squared, which are perfect squares. Now, to get the middle term, that would be twice the product of the square root of the first and the last terms. So that would be 2 times a, which is the square root of a squared, times b, which is the square root of b squared. Now, what are its factors? So the factors of this polynomial is equal to a plus b times a plus b, or simply you multiply the roots of the first and the last terms by itself. So you can also write it down in the power of 2, which is the quantity of a plus b raised to 2. How about if your perfect square trinomial has a minus operation? That would be a squared minus 2ab plus b squared. So the factors are a minus b times a minus b. So in the operation, if the first operation in the perfect square trinomial is minus, then the factors are also minus. So you can write it down as the quantity of a minus b raised to 2. Let's try this. Example number 1. Factor the expression n squared plus 16n plus 64. Solution. Step 1. Determine whether the first and the last term are perfect squares. So what is the first term? That's right, n squared. And the last term of the trinomial is 64. Let's check if they are perfect squares. N squared can be factored as n times n. Obviously, it can be expressed as the quantity of n raised to 2. So it is a perfect square. How about the quantity 64? It can be factored as 8 times 8. So it can be written as the quantity of 8 raised to 2. Therefore, the first and the last terms are perfect squares. Now, step 2. Determine whether the middle term is twice the product of the square root of the first and the last term. Again, let's check if it is twice the product of the square root of the first and the last term. So that would be 2 times n, which is the square root of n squared, and 8, which is the square root of 64. 2 times 8, which is 16, times the variable n. Is this the same with the middle term given? That's right. The middle term is twice the product of the square root of the first and the last term. Then we can factor this out. Step 3, since the conditions are satisfied, then the expression n squared plus 16n plus 64 is a perfect square trinomial. Then we can proceed with the factoring. Step 4. That would be equal to n plus 8 raised to 2, or n plus 8 times n plus 8. Example number 2. Factor the expression 4x squared minus 4x plus 1. Solution. Step 1. Identify or determine if the first and the last terms of the given trinomial are perfect squares. So the first term is 4x squared and the last term is 1. 4x squared can be factored out as 2x times 2x. Therefore, it can be written as the quantity of 2x raised to 2. Then it is a perfect square. How about the quantity 1? You can express this one as the factors 1 times 1. Therefore, it can be written as the quantity 1 raised to 2. Then the two terms are perfect squares. Step 2. Identify if the middle term are twice the product of the square root of the first and the last terms. Let's check. 2 times the square root of 4x squared, which is 2x, times the square root of 1, which is 1, is equal to 4x. Is this the same middle term in the given expression? That's right. Now we can proceed with step 3. It is a perfect square trinomial. Therefore, in step 4, you can factor this out by 2x minus 1 raised to 2, or 2x minus 1 times 2x minus 1. Again, where did we get 2x? It is the square root of the first term. How about 1? We get the quantity 1 as the square root of the last term, which is 1. How about the operation minus? We get the operation minus from the given expression, since the operation here is minus. So the factors of the expression are 2x minus 1 times 2x minus 1. Example number 3. Factor the expression x squared plus 14xy plus 49y squared. Solution. Step 1. What are the first and the last terms? The first and the last terms are x squared and 49y squared. We will check if they are perfect squares. X squared can be expressed as x times x. Then, it can be written as the quantity x raised to 2. How about 49y squared? It can be factored out as 7y times 7y because 7 times 7 is 49 and y times y is y squared. Then it can be expressed as the quantity of 7y raised to 2. Are they perfect squares? Very good. They are perfect squares. Step 2. Check the middle term if it is twice the product of the square roots of the first and the last terms. So 2 times what is the square root of x squared? That's correct. X times the square root of 49y squared. That's correct. 7y. So you multiply 2 times 7 is equal to 14 times the variables x and y. Is this the same as the given middle term in the expression? That's correct. Then in step 3, we can say that the given expression is a perfect square trinomial. We can proceed with the step 4 by factoring. The factors of x squared plus 14xy plus 49y squared are the quantity of x plus 7y squared. Where did we get the variable x? This one is the square root of the first term. How about 7y? This is the square root of the last term. And the operation plus. We base it from the operation of the given expression, which is plus. We can also write down the factors as x plus 7y times x plus 7y. Example number 4. Factor the expression 3x squared minus 18xy plus 27y squared. Kindly observe with the following terms. 3x squared, 18xy, 27y squared. Is there any common factor among the three? That's right. We need to factor out first their greatest common monomial factor. So solution. Step 1. Factor the greatest common monomial factor. So, the common monomial factor among the three is 3. That's right. Because 3, 18, and 27 has a GCF of 3. It means they can be divided by the number 3. Now, what are the remaining factors? So you divide each terms by the GCF to get the other factor. Let's try. So 3x squared divided by 3 is equal to x squared. Copy the operation minus, and then 18xy divided by 3. That would be 6xy. How about the last term? 27y squared divided by 3. That would be plus 9y squared. Then, our new expression is 3 times the quantity of x squared minus 6xy plus 9y squared. We can proceed with factoring perfect square trinomials. Step 1 or step 2. Identify if the first and the last term of the trinomial are perfect squares. So the first term is x squared and the last term is 9y squared. X squared can be expressed as x times x. Therefore, it is a perfect square. 9y squared can be factored out as 3y times 3y because 3 times 3 is 9 and y times y is y squared, which can be written as the quantity of 3y raised to 2. Then we can say that they are both perfect squares. Step 3. Identify if the middle term is twice the product of the square root of the first and the last terms. So that would be 2 times the square root of x squared, which is x, times the square root of 9y squared, which is 3y. So 2 times 3 is equal to 6 times the variables x and y. Is this the same expression as the middle term? So in step 4, we can say that this expression is a perfect square trinomial. So we can proceed with the step 5, which is factoring perfect square trinomial. So the factors are, of course, do not forget to write down the GCF of the three terms, which is 3 times x minus 3y raised to 3. Where did we get the variable x? Because it is the square root of x squared, which is x. And where did we get 3y? It is the square root of 9y squared. And we copied the operation from the expression, which is minus. We can also write it down as 3 times the quantity x minus 7y times x minus 7y. Example number 5. Factor the expression 9x squared plus 12xy plus 16y squared. Solution. Step 1. Determine if the first and the last terms are perfect squares. The first term is 9x squared and the last term is 16y squared. 9x squared can be factored out as 3x times 3x. So it can be written as the quantity 3x raised to 2. Next, 16y squared can be factored out as 4y times 4y, which can be written as the quantity of 4y raised to 2. Then, the last or the first and the last terms are perfect squares. How about step 2? Let's check if the middle term is twice the product of the square root of the first and the last terms. So that would be 2 times the square root of 9x squared, which is 3x, times the square root of the last term, which is 16y squared, which is 4y. So you multiply 2 times 3 times 4 is equal to 24 times the variables x and y. Now, is this the same expression with our middle term? No, they are not the same. Hence, this means that the trinomial is not a perfect square. Thus, you don't have to proceed to factoring perfect square trinomial. Now it's your turn. Thank you for watching. I hope you have learned something from me today. See ya!